This is Introduction to Mathematics Beginners Level. This course is facilitated by Limitless Learning TT, where it's all about learning on the go. Log into our website from any place at any time and view past videos, practice problems, and solutions for your course. For more information on the services we offer, please visit www.limitlesslearningtt.com. If you have any additional questions or concerns, please feel free to email us at info@limitlesslearningtt.com. In this lesson, we'll be exploring approximation. In the previous lesson, we spoke about what are numbers and place values, and in this lesson, we're going to explore approximation. Now, what does approximation mean? Approximation means close to, but not exact. What does that really mean? Let's look at an example. Suppose you were at KFC and you wanted a piece of chicken and they told you that it costs $9.99. Well, you could say, oh, that's almost $10. It isn't exactly $10, but it's close to. It's almost. So you would have approximated the $9.99 that's for that piece of chicken and said, well, roughly an estimate is about $10. So what you would have just done is used approximation. Another example, let's say that you were in a car and you were driving for about 56 minutes. You could say, oh gosh, we've been sitting in this car for about an hour. It's not quite an hour 60 minutes. It's not quite an hour, but it's close to. That's another example of approximation. So again, approximation means that you're close to a value, but you're not exactly that value. Now in this lesson, we will be approximating to the nearest 10. We'll learn to approximate to the nearest 100 and to the nearest 1,000. Now remember, we would have talked about tens, hundreds, and thousands, which are place values, in the last lesson that we did. So we're going to build on that information and use our new idea of approximation to see how that plays in. So let's look at approximating to the nearest 10. So let's just do a quick refresher. When we're talking about tens, it goes 10, 20, 30, 40, 50, 60, 70, 80, 90. Right? So if we're going to be approximating to the nearest 10, then that means that our answers can only be 10, 20, 30, 40, 50, 60, 70, 80, 90 for right now, right? In these examples that we're looking at, those are nearest tens, right? Tens can also continue to 100, 110, 120. That's counting in tens, okay? So it can go on to 100, 110, 120, and so forth. So those are tens, batches of tens. Now let's look at our question. We have the number 17. Now we know the number 17. This means that we have 7 ones and we have 1 10. Right? So 7 ones and 1 10, that makes up our number 17. And what we want to do is approximate 17 to the nearest 10. How are we going to do that? What we're going to do is we're going to look at the digit that represents ones. So the digit that represents ones in our case is 7. Now this is the rule. If the ones digit, so that's a digit that's in ones, is 5, so if it's the number 5, or it's a number that's more than 5, then the amount that's in the tens area increases by 1, and the 1 digit gets replaced by 0. So let's look and see what that really means. The digit that's in our ones section is 7. Okay, that's right here. 7 is greater than 5, right? 1, 2, 3, 4, 5, 6, 7. So 7 is greater than 5. So because 7 is greater than 5, we're going to look at our tens digit and we're going to increase it by 1. So when we increase 1 by 1, so that's 1 plus 1, we get 2, and then our ones digit gets replaced by 0. So when we approximate 17 to the nearest 10, we get 20. Now that may have seemed a little difficult to understand, but let's look at this same example with a number line and see how it actually makes sense. Okay, so if we have a number line here, and our number line, let's say it goes from 10 to 20, right? So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is our number line. (19) and 20, right? The number that we want to look at is 17. Now 17 is right here on our number line. Okay, so we're going to put a little dot at 17 to represent our number 17. Now when we're looking at tens, our values of tens is either 10 or 20. Now where is the blue dot closer to? Is it closer to 20 or is it closer to 10? It's closer to 20, right? It's 1, 2, 3 away from 20, whereas if it's 10, it's going to be 7 away from 10. So 17 is actually closer to 20. So when we approximate to the nearest 10, we can get 20. So to understand approximation, we can follow the rules here, which is in this little blue box, right? So we can follow the rules here, and then we can also use a number line to show that our answer is going to be the same. So let's look at another example. So let's say we wanted to approximate the number 14 to the nearest 10. Now the first thing we want to know is where are our ones and tens. So on top here, 4 is in the ones area and 1 is in the tens area. So according to our rules, that's our rules in this blue box here, it says if the ones digit is less than 5, so I'm reading from here, if the ones digit is less than 5, so our ones digit is 4. Is 4 less than 5? Yes, it is. 1, 2, 3, 4, then 5. So 4 is less than 5. So if our ones digit is less than 5, the amount of tens stays as it is, stays the same, right? So the amount of tens is currently 1. That's going to stay the same. And the ones digit gets replaced by 0. So 14 approximated to the nearest 10 is going to be 10. And we can look at that again on our number line. Let's represent 14 with a dot on our number line. So this is our number 14 here. We want to know, is 14 closer to 20 or is 14 closer to 10? And we can look at our number line and see that we only have 1, 2, 3, 4 that's between 10 and 14, whereas we have 1, 2, 3, 4, 5, 6 between 14 and 20. So therefore it must mean that 14, that's our blue dot, is closer to the number 10. Okay, so approximating to the nearest 10, you have to look and see two things. Is your number 5 or greater than 5? If it is 5 or it's greater than 5, we add the number 1 to our tens value and we replace the digit in ones with a 0. And if our ones number is less than 5, then we leave the amount of tens as it is and replace the ones digit with a 0. So let's look at another example, because the best way to understand these are to do as many examples as possible. So let's say that we want to approximate the number 45 to the nearest 10. Okay, so 45, we have under the 10 section, we have 4 tens and 5 ones. So the first thing we do is we're going to look at our digit under ones, and that's 5. So if the ones digit is 5 or more, so that means we're looking at here, if the ones digit is 5 or more, then the amount of tens increases by ones. So the amount of tens that we have here is 4. So 4 plus 1 is going to be 5. And then we replace the digit that's under ones with a 0. So 45 to the nearest 10 is going to be 50. Let's look at this one on a number line. On our number line, we're going to go from 40 to 50. So 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, and 50. Now, our number 45 is straight in the middle. Okay, and the number 45 that's straight in the middle, it means that 5, if we move 5 places, 1, 2, 3, 4, 5, it's 5 away from 40, but it's also 1, 2, 3, 4, 5 away from 50. So it's right in the middle. So it's actually the same distance away from 40 and the same distance away from 50. But because our rule says that if our digit is 5 or it's more than 5, it means we always approximate to the higher tens value. Right? So when our digit is 5, we still increase the number of tens and then replace the ones digit with a 0. Again, let's look at another example. We want to approximate the number 73 to the nearest 10. So that's 7 tens and 3 ones is our number 73. And we want to approximate to the nearest 10. So again, we're going to look at our ones digit. That's 3. 3 is less than 5. So if 3 is less than 5, it means this one here, less than 5. The amount of tens stays the same. The amount of tens we have is 7, so that stays the same, and then we replace the ones digit with a 0. So 73 approximated to the nearest 10 is going to be 70. And again, we can look at this on our number line. Let's say we had a number line going from 70 to 80. 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, and 80. Now I'm going to put a blue dot at my number 73 on the number line. So this is my number 73 on my number line. Now, is my blue dot closer to 70 or is it closer to 80? Well, it's definitely closer to 70. It's 1, 2, 3 away from 70 as opposed to 7 away from 80. So therefore, 73 is closer to 70 using my number line. And let's do one more example again with approximating to the nearest 10, just so that you understand. So let's make this one a little more challenging. Let's say we have the number 127 and we wanted to approximate this to the nearest 10. Now the first thing we want to do is put our tens T for tens, 0 for ones, and in this case we have 100. So we have 100, we have 2 tens, and we have 7 ones, right? So ones, tens, and this is hundreds. Okay, so we want to approximate to the nearest 10. Again, we're just going to follow the rules. We're looking at the ones digit. The ones digit is 7. 7 is more than 5. So if we have something that is more than 5, the amount of tens, so the amount of tens that we have here is 2. So the amount of tens increases by 1. We're going to put back the 1 for hundreds, and then we're looking at our tens value 2. 2 increases by 1, so 2 plus 1 becomes 3, and then our ones digit gets replaced by 0. Okay, so our hundreds isn't affected. All we're looking at is our ones value, and then we're going to see if we're going to adjust our tens values or not. So when we approximate 127 to the nearest 10, our answer is 130. And let's look at that again on a number line. So our number line is going to go from 120 to 130. 120, 121, 122, 123, 124, 125, 126, 127, 128, 129, and 130. Now we're going to put a blue dot at our value 127, which is right here. Now, is our blue dot closer to 130 or is it closer to 120? It is. It's closer to 130. It's 1, 2, 3 away from 130. So therefore, when we approximate 127 to the nearest 10, we get 130. So again, when we're approximating to the nearest 10, all we need to do is to remember our rule. And our rule states if we look at the ones digit and it's 5 or it's greater than 5, then we add 1 to the tens digit and replace the ones digit with a 0. If the ones digit is less than 5, so that's 0, 1, 2, 3, 4, that means that the amount of tens stays the same and the ones digit gets replaced by 0. So that's approximating to the nearest 10. Now we're going to use that same procedure, but we're going to adjust it when we're approximating to the nearest 100. So now we're going to be approximating to the nearest 10. These are our rules. We're going to be looking at the tens digit instead. So when we were approximating to the nearest 10, we looked at the ones digit. When we're going to approximate to the nearest 100, we're going to look at the tens digit. Right? If the tens digit is 5 or more than 5, then we increase the amount of hundreds by 1, and we're going to replace the digits in the tens and ones with zeros. If the if the tens digit is less than 5, the amount of hundreds stays the same, and the tens and ones digits get replaced by 0. So the best way to understand this is by looking at an example. Let's say we had 315. And we wanted to approximate this to the nearest 100. Now the first thing that we want to write out is these are ones, tens, and hundreds. Okay, so we have 3 hundreds, 1 10, and 5 ones. We want to approximate to the nearest 100. What we're going to be looking at is we're going to look at the tens digit. The tens digit is 1. Okay? 1 is less than 5. So if the tens digit is less than 5, that's our case because 1 is less than 5, then the amount of hundreds stays the same. So the amount of hundreds is going to remain as 3, and then we're going to replace the tens and ones digits with zeros. So this is 0 and 0. So 315 to the nearest hundred is 300. And again, let's look at this. It's not quite a number line, but it's writing our numbers in consecutive order from 300 to 400. So let's look at this chart here. So we have numbers going to the right in increasing order. So 300, 301, 302, 303, 304, all the way to 400. So 315, we have that highlighted here. And we can already see 315 is closer to the top value, which is 300, than closer to the bottom value, which is 400. So therefore, 315 to the nearest 100 is going to be 300. Okay, so let's look at another example. So our example is we have 369, and we want to approximate this to the nearest 100. Now again, we have 300s, 6 tens, and in this case we have 9 ones, and we want to look at our tens value. Our tens value here is going to be 6. 6 is more than 5. So if 6 is more than 5, the amount of hundreds that we have, which is 3, is going to increase by 1. So 3 plus 1 is 4. And our tens and 1 digits get replaced with zeros. So 369 approximated to the nearest 100 is going to be 400. And then again, we can look at that chart and see how true that is. So looking at this chart again, we're going to circle on number 369. That's right here. And it's in the lower half of our numbers. So we can see that 369 is going to be closer to 400 than 300 just by looking at this chart. So again, when you're approximating to the nearest 100, you're going to look at the value of tens. If that digit is 5 or it's more than 5, you're going to add 1 to the hundreds and replace tens and ones digits with zeros. If you look at the tens digit and it's less than 5, so that's 0, 1, 2, 3, or 4, then you're going to leave the digit under the hundreds as it is, but still replace the digits under tens and ones with zeros. Let's look at another example. Let's suppose we have the number 2034. Okay? So O represents ones, T is tens, H is hundreds, and let's put TH as thousands, right? THOU. Right, so thousands, hundreds, tens, and ones. We want to approximate to the nearest 100. If we're approximating to the nearest 100, we are looking at our tens values. Our tens value is 3. 3 is less than 5, so less than 5. If the tens digit is less than 5, the amount of hundreds stays the same. This is my amount of hundreds is 0. That stays the same. So I'm going to put back my thousands because no one cares about that right now. Put back my hundreds. It's going to stay the same as 0. And then the tens and ones digits get replaced by 0. So I'm going to replace with 0 and 0. So therefore, 2034 to the nearest 100 is 2000. Okay, so let's look at a chart to see how that looks. Okay, so our chart starts from 2000 and then we put in the next 100 numbers, right? So 2000 to 2100. So these are 100 numbers here between 2000 and 2100, right? Or 2100. And what we're looking for is 2034. That's right here. It's already highlighted. And we can already tell that it has less numbers, or it's closer to 2000 than it is to 2100. So using our chart again, we're able to tell, depending on where the number lies, if it's closer to the lower number or if it's closer to the higher hundreds number. Okay, so we would have used the chart and we can see that our number is closer to 2000 than it is to 2100. Let's look at one more example. So let's say the number that we wanted to approximate is going to be 856. Sorry. Right, so this is ones, this is our tens value, and this is hundreds. So we have 8 hundreds, 5 tens, and 6 ones, and we want to approximate to the nearest hundred. Nearest hundred. So again, we're going to look at our tens value. Our tens value is 5. So if our tens digit is 5, or more than 5, then the amount of hundreds increases by 1. So 8 plus 1 is going to be 9. And then the tens and ones digits get replaced by 0. 0, 0. So 856 to the nearest hundred is 900. Let's do another example. Suppose we have the number 7,395. Okay, so again, this represents ones. These are my tens. These are my hundreds. And these are my thousands. Okay, so I have 3 hundreds, 9 tens, and 5 ones. And again, I want to approximate to the nearest hundred. I am going to look at my tens digit. My tens digit is 9. Okay, 9 is more than 5. So if I'm more than 5, what do I do again? I increase the number of hundreds by 1. So 3 plus 1 is 4. I put back my 7,000. Right, and then my tens and ones digits get replaced by zeros. So to the nearest hundred, 7,395 to the nearest hundred is going to be 7,400. Okay, so far we have learned how to approximate to the nearest 10 and how to approximate to the nearest 100. So when we're approximating to the nearest 10, we're looking at the ones digits. When we're approximating to the nearest 100, we're looking at the tens digit. So if we had to approximate to the nearest 1,000, which digit do you think we'll be looking at? Hundreds, yes, we'll be looking at the hundreds digit. So now I'm going to show you how to approximate to the nearest 1,000. Okay, so now we're talking about approximating to the nearest 1,000. So again, now we're looking at the hundreds digit. If it's 5 or more than 5, then we're going to increase the amount of thousands by 1. And then the hundreds, tens, and ones digits get replaced by 0. And then if we're going to look at the 100 digits, if it's less than 5, then the amount of thousands will stay the same. and the hundreds, tens, and ones digits get replaced by 0. So let's look at an example. Let's say we had 2034. Okay, we are approximating to the nearest thousand. So let's put this as ones, this is tens, this is hundreds, and this is thousands. Okay, so we look at our hundreds digit. That's right here. Our hundreds digit is 0. 0 is less than 5. So if we're less than 5, the amount of thousands stays the same. So that's 2. And then our hundreds, tens, and ones digits get replaced by 0. So our hundreds digits gets replaced by 0. Our tens digit replaced by 0, and our ones digit replaced by 0. So 2034 to the nearest thousand is 2000. Let's look at another example. So let's suppose that we had 7,777, and we want to approximate this to the nearest thousand. We're going to look at our hundreds digit. Our hundreds digit is 7. 7 is more than 5. More than 5. So therefore, the amount of thousands increases by 1. So 7 plus 1 becomes 8. So our thousands increases by 1. And then our hundreds, tens, and ones, those digits get replaced by 0. So 100 digits is 0. Our 10 digits is going to be 0. And our 1 digit is going to be 0. So 7,777 to the nearest thousand is going to be 8,000. Let's look at another example. Suppose we had 4,516, and again, we want to approximate to the nearest thousand. Again, we're going to look at our hundreds digits. Our 100 digits is 5. So if the 100 digits is 5, right, so 5 or more than 5, then we increase the number of thousands by 1. So 4 plus 1 is 5. And then the hundreds, tens, and ones digits get replaced by 0. So hundreds digits gets replaced by 0. Tens digits gets replaced by 0. Ones digits gets replaced by 0. So 4,516 to the nearest thousand is going to be 5,000. Simple enough. So again, these are the same rules that we've been using for 10, hundreds, and now thousands. The only thing that changes is the digit that you look at. Right, so for nearest 10, you looked at the ones digit. For the nearest 100, you looked at the tens digit. For the nearest 1,000, you're looking at the hundreds digit. So let's try one that's a little more challenging. So this is going to be a really good challenging example. Okay, so let's suppose that we have the number 9,843. Okay, so we have the number 9,843, and we want to approximate to the nearest thousand. Now we know that we need to look at our hundreds digit. Our hundreds digit is 8. That's right here. Now 8 is more than 5. Okay, so more than 5. We're looking at this one. That means that the amount of thousands increases by 1. So our amount of thousands is going to increase by 1. 9 plus 1 is 10. However, we know that when we have digits in places for numbers in our place values, we can't put the number 10 under thousands, right? It must mean that 0, right? So what we have is 10,000, so it must mean that 0 corresponds to thousands, and this 1 that's in the 10 is going to come in this place value. That is going to be tens of thousands. Tens of thousands. So when we add 1 to 9, we get 10. But we can't put 2 digits under thousands, right? So that 10 is going to represent 1 10 of thousands, 0 thousands, and then we continue with the rest. We're going to replace our hundreds, tens, and ones with zeros. Hundreds get replaced with 0, tens get replaced with 0, and ones get replaced with 0. So let me explain that one more time. Okay, so we have the number 9,843. We want to approximate to the nearest thousand. That means we need to look at our hundreds digits. Again, our hundreds digits is more than 5, so we have to add 1 to our thousands. This is thousands digit. We have to add 1 to this. When we add 1 to 9, we get 10, but we can't put 10 under the digits for thousands. We can only put 1 digit under thousands. So we put the 0 under thousands and the 1 under the new place value for tens of thousands, and then we continue with what our rule tells us to do. We're going to replace hundreds value with 0, thousand value with 0, and ones value with 0. So when we approximate 9,843 to the nearest thousand, we actually get 10,000. So 9,843 to the nearest thousand is going to be 10,000. Okay, so that brings us to the end of looking to approximation to the nearest 10, to the nearest 100, and to the nearest 1,000. And now what we're going to do is we are going to work on some practice problems using the rules that we had from before. Okay, so let's work now on some practice problems. So before we go on to practice problems, I would have just put all the rules for each one of the approximations next to each other. Okay, so if we're going to recap. If we're approximating to the nearest 10, we look at the ones digit. If it's 5 or more than 5, then we increase the amount of tens by 1, and then the ones digit gets replaced by a 0. If the ones digit is less than 5, then we keep the amount of tens as it is and just replace the ones digit with a 0. This is if we're approximating to the nearest 10. If we're approximating to the nearest 100, we're looking at the tens digit. So if the tens digit is 5 or more than 5, then the amount of hundreds increases by 1, and we're going to replace the tens and ones digits with zeros. And then if the tens digit is less than 5, we're going to keep the amount of hundreds as it is, but we're going to replace the tens and ones digits with zeros. And then if we approximate to 1,000, we're looking at the hundreds digit. If it's 5 or more, then the amount of thousands is going to increase by 1, and then we're going to replace hundreds, tens, and ones with zeros. And if the hundreds digit is less than 5, then we're going to keep the amount of thousands as it is, and we're going to replace hundreds, tens, and ones with zeros. So that's a recap of what we would have done, approximating to the nearest 10, to the nearest 100, and to the nearest 1,000. So now we're moving on to practice problem. So we want to find the number 1,218 to the nearest 10, to the nearest 100, and to the nearest 1,000. So the first thing we're going to do is write our number, 1,218. This is ones, tens, hundreds, and thousands. Okay, so the first thing we're going to do is we're going to work to the nearest 10. When we're working to the nearest 10, so I'm going to put this here. Nearest 10. When we're working to the nearest 10, we look at the ones digit. The ones digit is 8, right? 8 is going to be more than 5. So that's the one digit. It's going to be more than 5. So we're going to increase the number of tens by 1. So that's going to be 2. And we're going to replace the 1 with 0. And then we're going to just write the remaining thousands and hundreds. So 1,218 to the nearest 10. Is 1,220. Next, we're going to look at the same number, 1,218, and now we're looking at it to the nearest 100. So we're looking at the nearest 100. When we're looking at the nearest 100, the digit that we look at is going to be tens. So the number tens, right, is going to be, the number of tens is 1, and 1 is less than 5. So according to our rules, we're approximating to the nearest 100, and we're looking at the tens digit. If the tens digit is less than 5, that means the amount of hundreds remain the same. So the amount of hundreds remain the same at 2. And then we are going to replace tens and ones with 0. So tens will be 0, and ones will be 0, and then we put back our 1,000 as 1,000. So 1,218 to the nearest 100 is 1,200. Okay, and next we're going to look at to the nearest 1,000. So to the nearest 1,000 means that we are looking at our hundreds digit. And our hundreds digit is 2. 2 is less than 5. If it's less than 5, we keep the amount of thousands as is. So the amount of thousands is 1. We keep that as is. And then we replace the tens and ones with 0. So our hundreds, tens, and ones, our 100 tens and ones are replaced with 0. 0, 0, and 0. So to the nearest 1,000, our answer is going to be 1,000. So 1,218 to the nearest 10 is 1,220. 1,218 to the nearest 100 is 1,200. And 1,218 to the nearest 1,000 is 1,000. Let's do one last practice problem. Our final problem is to find 981 to the nearest 10, to the nearest 100, and to the nearest 1,000. So we're going to write down our number, 981, and this is ones, tens, and hundreds. Okay, so first we're going to look at to the nearest 10. Again, remember, when we're looking at the nearest 10, the digit that we look at is ones. Right? We have 1, 1, and that 1 is less than 5. So according to our rules, it is 1 is less than 5. So that means that the amount of tens that we have stays the same. So the amount of tens is going to stay the same. And we're going to replace ones, the ones digit, with 0. And then we just put back our hundreds. So to the nearest 10, to the nearest 10, 981 will be 980. Now we're going to look at 981 to the nearest 100. So nearest 100. Again, when we're looking at nearest 100, we look at our tens digit. Our tens digit in this case is 8. 8 is more than 5. So according to our rules, if we have a digit, which is 8, that is more than 5, we increase the amount of hundreds by 1, and then we replace with zeros. So we're going to increase the amount of hundreds by 1. So that is 9 plus 1, which is 10. Right? Now remember, we can't put the number 10 in hundreds. 0 has to go under hundreds, and 1 has to go under thousands. Right, so we add, remember again what we're doing. We'll look at our tens digit, it's 8. That means we have to add 1 to our hundreds digit. So our hundreds digit is 9. 9 plus 1 is 10. So that means we have to put the 0 under hundreds and the 1 under thousand. That's giving us our 10. And then we're going to replace our tens and ones digits with zeros. So when we have 981 to the nearest 100, our answer is 1,000. Okay? And the last part, we want to find 981 to the nearest 1,000. Okay? So when we're looking at the nearest 1,000, we look at our hundreds digit. Our hundreds digit is 9. Okay? In this case, what is our 1,000 digit? Our 1,000 digit, we don't have one. So technically, it's 0. We don't have any 1,000 in this number. Right? So we look at our hundreds digit, and according to our rules, if our hundreds digit is more than 5, because remember our hundreds digit is 9, so if it's more than 5, which is here, we're going to add 1 to the number of thousands. So we're going to add 1 to the number of thousands. The number of thousands that we currently have is none. So none, which is 0, plus 1 is going to give me 1. So I add 1 to my number of thousands, which is 0. And then I replace my hundreds, tens, and ones with 0. So my hundreds, I replace with 0. My tens, I replace with 0. And my ones, I replace with 0. So 981 to the nearest 1,000 is 1,000. So that's the end of our practice problems and the end of this lesson. Again, this is Introduction to Mathematics Beginners Level. This course is facilitated by Limitless Learning TT, where it's all about learning on the go. Log into our website from any place at any time and view past videos, practice problems, and solutions for your course. more information on the services we offer, you can visit our website, which is www.limitlesslearningtt.com. And if you have any additional questions or concerns, you can always send us an email at info@limitlesslearningtt.com.